So before I actually start covering the material in 9.1, I wanted to do a breakdown of what we knew from exam 2 and before, what we learned in 8.1, and then what you're going to see in 9.1. Because there's a lot of formulas, and I just want to briefly break down when and why we use those formulas. And I'm doing this before I show you 9.1. So some of the stuff down at the bottom of the page might get a little confusing, but it's good to see it now and then see it again when you see the next video. So let's pause the video and go ahead and write this down, and then when you come back, I will read it and explain some more. Go ahead and pause. All right, so what we covered, this is the probability distribution. This is basic, what I'm getting at is anything from exam 2 and before. So here we were given the population mean and the standard deviation. And when we did that, we knew that mu sub x was just equal to mu. So we just said the mean of whatever probability distribution we're working with is just equal to the mean that we were given. Standard deviation of x, which just means the standard deviation of the population we're working with is just, or the size, the thing we're working with is just the population standard deviation. And z is what we're used to, the x minus mu over sigma. And in 8.1, what you covered was this. So go ahead and pause the video again, and I will read and then talk about its mean and standard deviation. Okay, go ahead and pause. So here, this is a sampling distribution. We're dealing with many different samples of size n, and the population and mean and standard deviation are also known. I should have said known here. Or are given. All right. But the key thing, and we use x bar because we're using a sample. So the key thing here is to note that we have a sample, and each sample can vary and be different. So if we were taking, let's say, of a university that has 20,000 students, if we took a random sample of 50 students IQ, and we got the mean and standard deviation of just those 50 students, and then we did it again for a different sample, and then did it again for a different sample. Each time we would get different mean and a different standard deviation. So that's where this sampling distribution comes into play, and that's why we have to use different means and different standard deviations. So here, mu sub x bar. Remember, x bar is telling you you're dealing with a sample. So it's important to keep the notation correct. That's just equal to the mean that you're given. So you'd be given that, and then the standard deviation of x bar, meaning the sample standard deviation, is different. So far everything's been the same as up here. We're just using the same population mean. But since we're dealing with a lot of different samples, we need to take into account that each sample can be different. Up here we didn't care. Here, now we do care. We want to take into account that each of the samples that we take from this big population can be different. So that's why we take the standard deviation and divide it by the square root of the sample size. All right? And z, it still starts out the same. It's still x minus the mean divided by the standard deviation. But now, since we have a different formula for the standard deviation, that's what changes. So now z, when we're dealing with a sampling distribution, it's x minus the mean, and then that's all divided by the standard deviation divided by the square root of n. All right, so I'm just trying to keep these two in focus and in line, so that way you know when to use each one. This one's going to be a little bit of writing, and this is 9.1 info. So go ahead and pause and write this, and then come back when you're ready. All right, so the population mean and standard deviation are unknown. So what's going to happen in these problems is I'll say, out of these 1,000 students, X amount have this certain characteristic. The sample size n is from a population in which each individual either does or does not have a certain characteristic. We use p hat, so it's a proportion. This proportion of this group that we're looking at is p hat. We use p hat to estimate the mean and the standard deviation. So notice here, like it says, we don't know the actual mean and standard deviation of the population. We just know of this particular group and study. So we take a proportion, p hat. Confidence intervals are used here as well, and I'm not going to cover those right now, but more to come on those. But I just wanted to show you what the mean and standard deviation are here, and then one little check that we had to do. So before we get to the check, so our mean is mu sub pi hat. So see, it's similar to what we have here. That's why the little subscript makes a difference. Here we know what we were given the population mean. Here we know we were dealing with a sample, and here we know we're dealing with a proportion now, and that's just equal to p, which and then the standard deviation of p hat. So the sample standard the proportion standard deviation, excuse me, is equal to this, which it's a little hard to see on the screen. It's a big square root, and then that's p, open a parenthesis, 1 minus p, close a parenthesis, and divided by n, and all of that is under the square root. So notice the mean doesn't really change from distribution or a proportion, but the standard deviation definitely does. All right, and then when we're dealing with population proportions, p hat or p or whatever you see, you have to check these two things. All right, so you'll see these in some of the videos I post, and I wanted you to be aware when you see these that it's nothing to freak out about. I just wanted to get it out here. You want to check these two things: n, the size of the sample; p, the proportion that we just found over here; and then times 1 minus p. Those multiplied together have to be greater than or equal to 10. And 2, the sample size, little n, has to be less than or equal to 5% of capital N. So what this is saying here is that capital N is the population size, and it's multiplying by 0.05. So it's saying the sample size that you have or that you take must be less than or equal to 5% times the population. All right, so I know this part's new. We're going to cover some more of that here in a minute. That's it for now.